Hello, thank you for joining this session. We will be exploring AWS Copilot, which is an easy way of getting started with containers on AWS. In this session, we will talk about AWS Copilot, why do you need it, what is it, and how do you work with it. So, I will be showing two detailed demos towards the end of the presentation, so stay tuned. So, let me tell you a recent conversation I had with a friend. He said, Rohini, I am exploring containers for my web application and it's awesome. Can you tell me a bit more as who all are using containers and why? Well, containers are a powerful way for developers to package and deploy their applications. They are lightweight and provide a consistent, portable software development environment for applications to easily run and scale anywhere. Building and deploying microservices, running batch jobs for machine learning applications, and even for moving existing applications into the cloud are just some of the popular use cases for containers. Well, containers are simple. You still need to worry about more questions like what is the infrastructure you're going to need to run these containers are? How do you provision and maintain the infrastructure? How do you set up your services easily? How would you decide when to scale out your services and to scale down your services as well? And further, how do you test without breaking your production? Fear not, AWS is here. Now, AWS has the broadest set of services, technologies, and tools to build applications on containers, as well as deep integrations with some open source and AWS partner technologies. There is no right way to build on AWS. And indeed, our large customers build in multiple ways. They use the core container orchestrators like Amazon ECS and EKS and container and non-container technologies with multiple choice of data plane options like EC2 and Fargate and ARM and AMD and Intel, while also having operating system choices like Amazon Linux, Windows, and the new container operating system Bottlerocket. We provide a lot of different tools and abstractions, observability, security, networking, CI/CD related tools as well. Now, as I'm saying this, some of you, like my friend, who would be new to the AWS cloud or just want to simply test their containers application on cloud, are wondering how do I navigate through all these tech? And as my friend was pretty impressed and a little overwhelmed, but still wanted to know more as what needs to be done. So we discussed using a sample architecture like this one, where a client sends request to let's say a load balancer which could be processed by service A or B. These services internally talk to a backend API service and a database. Great. It's a simple 5 resources application. However, before we get to this, you have to set up a base network infrastructure on AWS. In AWS, you set up a virtual private cloud, which is the logical isolation of network just for you. Now, VPC has more components to set up internally, and it is a best practice to set up separate network infrastructure for your different production and test environments. You can easily do this with the infrastructure as code tool like CloudFormation or Terraform. I have provided a CloudFormation template in my GitHub repo, which you can use to begin with and then configure it further. Once you've set up your base infrastructure, you have to set up these 5 resources and their configurations, like application load balancer, the HTTP listener, the rules, the target groups, the service discovery, the ECS service task definitions, the container registry, and finally the database as well. So what we want at a high level is a load balancer to take client request for our application, which will then forward it to your application, and your application would have some kind of service mesh, and you can use a container orchestrator to automate the deployment, management, scaling, and networking of your containers. Now you could host them on servers or a serverless platform and use a database of your choice for that particular service. You would then need a continuous delivery pipeline for your developers so they can release your newer application code seamlessly onto your application setup. And of course, your system needs some kind of monitoring for your metrics, for your logs, for your traces, for your operational excellence. So for simplicity, let's categorize them into build, release, and operate functionalities. Now, at AWS or in the AWS world, these will relate to some of the AWS services. So, for example, your load balancer would become an application load balancer in AWS, which integrates seamlessly with orchestrators like Amazon ECS. Amazon ECS is very simple to start with. It decreases the number of decisions that customers have to make around, compute and network and security configurations. Some of them we discussed previously. Now, ECS is very friendly and familiar to developers with experience using Docker. ECS is great starting point if you want to move quickly. So you can use services like CloudWatch for monitoring and the Code Suite services for continuous delivery. You could also use the Amazon Elastic Container Registry or ECR to share and deploy your container images publicly or privately. So my friend, who like most of you is new to the platform, is now worried about how many items they have to learn before they can get started. Don't take me wrong. Many of our customers love the ability of control they have on individual components they can host on AWS. They want this level of granularity. However, many customers would want an easy way to get set up and go. And for them, well, what if I told you you can do all of this that we discussed with a very simple tool? A simple tool with a couple of commands and you can deploy all of this that we discussed? That's where Copilot comes in. Using CloudFormation, it will automate all of this so you can only work on building efficient containers, and Copilot will take care of how you build, how you release, and how you operate on your code. In an interactive way, it deploys some standard application environments for you to quickly set up your microservices application. AWS Copilot is an open source command line interface, and it makes it easy for developers to build, release, and operate production ready containerized applications on AWS services like AWS App Runner, Amazon ECS, and AWS Fargate. You can start simple with just a Docker file and then grow with more add ons. You can also work with multiple AWS accounts and regions. You can add more automation and have more visibility in your application's health. Don't worry, we will see all of this in our upcoming demo. So Copilot will set up all the infrastructure you need for your services to run, right? But how does it know what kind of infrastructure to use? So when you're setting up a service, Copilot will ask you, what kind of service do you want to build? Now, please note, as until now or even after in this session, if you're new to AWS and if any of these services seem confusing, ignore it. You don't need to know all these AWS services to work with AWS Copilot. Just focus on the type of services and the use cases that we are going to discuss in this slide. If you want your service to serve, let's say, internet-facing traffic, then you have two options: request-driven web service and load-balanced web service. The request-driven web service will provision an AWS App Runner service to run your microservice. It auto-scales your instances based on the incoming traffic for your application and scales down to baseline instances when there is no traffic. Now, this option is more cost-effective for the HTTP services with sudden bursts in request volumes or if you have low request volumes. So remember, for any sudden or low request volumes, use the request-driven web service. Load-balanced web service will provision an application load balancer, security groups, ECS on Fargate to run your service. This option is suitable for HTTP services that have a steady request volume and that need access to resources in a VPC or need some extra configuration. So remember, this is for low or spiky, sudden burst kind of a request volume, and a load balanced web service is more suitable for steady workload. If you want a service that cannot be accessed externally but only from other services within your application, you can create a backend service. Copilot will provision an ECS service running on Fargate, but there will not be any internet facing endpoints. And finally, Schedule jobs comprising of a step function state machine for retrying on failures and an event engine rule to trigger the state machines. So let's check out the first demo that where we will just simply install Copilot and deploy a very sample app with a simple one-line command. So the first time you are working with a fresh environment, this is a fresh Cloud9 IDE environment. I've not installed Copilot. I want to check if my AWS credentials are configured correctly. So there is no access key secret key here. I am going to provide maybe a region, a default region here to be AP Southeast 2, and there is no default output. The reason I'm doing this is because I've already associated an IAM role to this Cloud9 environment. So that gives it all the permissions that it needs to talk to different AWS services. Now, once that is done, the only command that you need for installing Copilot is in the AWS Copilot documentation. So if you want to know more about the installation process, just go to the AWS Copilot documentation and you can find the installing section. How do you install this? So this one is showing you for Mac operating system, but if you want to install it manually, you can see how you can do this. So what I'm doing here is simply copy pasting this command, going here and pasting it here. The moment I do that, it will download Copilot, make modifications, and it will install it. And in the end, it will also show you the Copilot help section. So this is the help section that it is automatically showcasing because of this command. And in the help section, you can see that you can do in it. You can individually create the app environment services, which we'll see in the next demo, and you can create pipelines and etc. Now, similarly, you can also check out the version. So this version is 1.8.0 that I'm using for this particular demo. Now, what I will do is I will simply clone one of the sample applications that AWS has for Copilot. And that app is called as Amazon ECA CLI sample app. Okay, I'm calling it as demo app. So let's do that. Awesome. So let's go to the demo app and just run one command. Let's show you one command. So the command is Copilot init. The moment I do Copilot init, it will say that would you like to use one of the existing applications? Now, because I have been playing with Copilot for a while, it will ask me that question. But it may not ask you this question if you're doing this the first time. Okay. So I'm going to say, no, I don't want to use an existing application. I want to create a new application. Great. So let's create a new application. What would you like to name your application? So let me call it new sample app. Okay. The moment I give it a name, it will ask me which workload type best represents the architecture for this particular application. So there are four options that I have. Either I can have a request driven web service, which is created by a new service that we called as app runner. Or do you want to create a load balanced web service, which will have an internet facing load balancer, some services behind it, and those services could be talking to other services or databases in the backend? Or do you want a backend service? So it doesn't have an internet facing a load balancer. It is for services to use internally. That's why it's called as a backend service. And the last one is the schedule job. This is like a state machine job that you want to just create for your particular application. So what kind of application are we looking at? Now, this particular sample application is a load balanced web service. So I'm just going to give it that name, that option. Okay, so it is a load balanced web service. What do you want to name this particular load balanced web service? Let me call it maybe something like API. Okay, so where is the Docker file that you're using for this API? Now, because I am in that folder of demo app, it has automatically picked up the Docker file. Okay, so there are two important files in this folder. One is the Docker file, which is a simple Docker file as it can get, and there is an index.html to showcase something for us. So it has automatically picked up. But if you don't want to provide this Docker file, you want to provide some custom path for your Docker file, you can also provide that. Or you can provide an existing image. Instead, you don't want to build a new image, Docker image, you can just provide an existing image. I want to use this Docker file, so let's say Docker file. Okay, so what port do you want the customer traffic to be sent to? Okay, let's go with the default 80. Great. We'll set up the load balanced web service name API in the application new sample app that is listening on port 80. What happens here is it is going to create the infrastructure to manage all the services and jobs that are going to create a new sample app. And if you go and check your folders, it has now created a new folder called as Copilot. So when whatever it is going to create new, if it needs some files to be created like manifest files or more YAML files for configuration, it will create in this Copilot folder. So you go ahead and change these files in the Copilot folder, push that update, and automatically your application will now implement all those configurations that you've provided in the manifest or the YAML files. Now this takes a little bit about like 5 to 10 minutes because it is deploying a lot of things into your AWS account. We will see all of that in detail in the next demo. But if I had to show you that you can do everything that you want to do that we did right now with just one click, use one command, what you have to do is this command. So if I mention this command where Copilot initiate an application called as demo, name it this, it's a load balancer, its Docker file is here, and just go ahead and deploy. The moment I execute this command, whatever that interactive workflow you saw, that all can be avoided. You can just run one single command and everything that you want will be created automatically. So now if you go back and you can see, okay, it has created the infrastructure to manage the services and jobs under the application new sample app. Okay. So now it has also wrote the manifest file in Copilot API manifest. Yes, there is an API folder under Copilot and that has a manifest file. It has also created ECR repositories. ECR, as we discussed, is a repository for storing all your Docker images. So it is a service that AWS provides where you can store your Docker images privately or you can also store them publicly. Right now, it has stored all of these privately. All right, you're all set for your local development. Would you like to deploy a test environment? Yes, we want to deploy a test environment. As of now, it has just created the Docker file and stored it in the ECR repository and created some base infrastructure for your environment. Now it will go ahead and create more infrastructure that it will need to run these tasks or to create the Docker containers from your Docker file onto your AWS environment. While it is doing that, let's quickly go ahead and check out the manifest.yaml file. Here you can change the name if you want. You can change the type of the service. In HTTP, you can also provide the path. What is the image? It's a Docker file. What's the port? You can also change if you want the CPU, memory, and how many tasks it should create by default. And we will see some of these variables in the next demo. So while it is doing this, let me fast forward it and show you what's the end result of this activity. Great. So it has completed deploying my API service. I can go ahead and access it at this particular location. So let's open this link in a new tab. And that's it. My application has been deployed. It's a simple application. There is nothing here to do. But what did it do for so long that for 275 seconds, and before that, it took a lot of time to create a lot of things that I need for creating my infrastructure. So let me go scroll up a little. So initially, it created infrastructure related items. So all the networking information and all the security details that I need, like virtual private cloud or IAM roles or security groups that I need for this particular deployment. It has created those. It has created those based on the dependencies that they have. Once that is done, it has then built the Docker image from your Docker file. Once that is done, it has also pushed this Docker file to a repository in your account. So it has pushed it to a repository in your particular account. It has created a code commit repository and pushed it there. Once that is done, it has gone ahead and updated all your environment resources so that, hey, new service has been created and you need to now deploy the Docker image or the Docker container onto this service. So it goes ahead and creates a lot of items, a lot of rules and application load balancer, and so on and so forth. So let's scroll down a little bit low, and it updates a lot of your infrastructure. And finally, it creates the tasks, which is like Docker containers on your environment, on your API test environment, and it has deployed this API service, which we can now access using the URL that it is providing for the ALB. Now, this is a simple deployment. With just one command, where we provided these details, it has created an entire load balanced web application for us, and we can now access this web application using this URL. Now you will say, hey Noini, now that we have deployed the application and tested it, how do I delete it and clean up all the resources so I stop paying for it? It is a very good practice to go ahead and clean up all the resources that you've added temporarily. So to delete this application, you use the simple Copilot command called as Copilot app delete. So this will just go ahead and delete the application. So it is asking, are you sure you want to delete the application new sample app? So you say yes. If you had multiple apps, it would have confirmed which app do you want to delete. Now delete the service API first for the environment, and then it will go ahead and delete everything from the environments to the services and to the application infrastructure that it had created for this particular new sample app. This is a best practice, so remember to delete it when you've done to stop paying for the resources. So that was a demo where you could deploy a sample app with just one command, and it creates everything that you need for that sample application. Now, our real world applications may not be so simple. We may be working with some kind of microservices applications. And hence, the second demo will deploy a sample microservices application that has three microservices: users, posts, and threads. And the original architecture is like this, where it hosts all of these services using containers, of course, on EC2 instances in a server format. And they have an application load balancer. Now, I will use this same application to be hosted using AWS Copilot. So when we are working with Copilot, we will first create an application. Okay, so we will initialize a Copilot application. We will do all these components individually, unlike the first demo where we did everything in one command. Here we will create all of them individually. So the first thing you create is the application. Then you create your test environment. Then we will create our prod environment. Okay, so the test environment is created in AP Southeast 2, while the production environment is created in AP Northeast 1. These are in two different regions. So I will also show you how you can create them in two different regions. Then we will also create a release pipeline, which will automate whenever there is a code change for, let's say, for the user service, it will automatically pick that code change that I've made into my GitHub account, GitHub repository, and it will automatically build the container images with your latest code, deploy it to your test, and once you approve, it will deploy it to your production environment. So let's quickly check out that demo. For this demo, I'm using a blank Cloud9 environment again. So I can show you how you can again, install the Copilot command line to creating the environment fresh. So I've already copied the command to install Copilot, and it will just simple download it and configure it, and it will like show me Copilot help. So these are the help options. Or you can get started with init, or you can just have initialize each app environment and service. And as we saw in the architecture diagram, we will be doing that. We'll also be deploying a pipeline, and we'll see some more information. And here we are using the Copilot version 1.8.0. This is important because Copilot keeps adding more and more features. And so it's important to know which version you're using and which version I'm demoing, so to know what features are available with this. Now, with that, let's create a clone one of my repositories that is in GitHub, and I've already provided that. I'll keep providing the link for that. So I'm just cloning that repository here in the local, it's AWS Copilot demo. Once it's cloned, you can see that there are 3 folders in this repository. There is images, infrastructures, and services, and there's a README for you to follow step-by-step process. In the services, you can find the 3 services: the post, threads, and users service that we will be deploying. So in the user service, you can check out that there are some JSON files. There is a Docker file, which is a very simple Docker file. Nothing amazing about it. It's just a simple example Node.js application. This could be something similar to one of your microservices application. So let's go ahead, clear this. Let me increase the window. And what we'll do is we'll do Copilot init. This is what we did in the previous demo, but instead of that, we will not only create that, we'll individually create all these components. So you'll say Copilot app init. This will help you create these individual components as per the architecture diagram that we saw. Now, I would want to call it social media app or SM app, whichever, like whatever you want to name it. Once I say that and press enter, it will create the infrastructure to manage the services and jobs under the application SM app. So all this, you can also see that there's a Copilot folder. There, I should have entered the folder itself, the Copilot demo, and run this command. But nevertheless, I've moved that Copilot folder inside. And right now there is no files inside it. This will be created later on as we keep adding more items to our demo itself. Let's wait for a few seconds. In this entire demo, you will have a few seconds of silences while I wait for the commands to do their magic in the backend and come back and respond to me. Now, if you want to, this is not compulsory, but if you want to check out what is happening in the backend, and this is for enthusiasts, go to console and go to CloudFormation, and you will see what is happening in the CloudFormation section. Here you will see that the Copilot commands are actually running CloudFormation templates and creating CloudFormation stacks in the backend. Now it has created these 2 roles for this particular application. So every time you create a new application, it will create those roles. So yes, it has created the infrastructure. It has created the directory for Copilot, which will hold our manifest files. So let's do the right thing and go inside the Copilot directory itself. Now that we are inside, we have seen the folder. We will now go ahead and create the environment that is needed inside this Copilot application. So the command will be Copilot environment init, and we will name it test, and we'll create it in another region. So it could be AP Southeast 1, AP Southeast 2. Okay, so this is just to make sure you understand how you can create multi-region environments. Now here it will ask you temporary credentials, or do you want to use the profile that you've already created using AWS Configure. Now, note that my AWS Configure doesn't really have any credentials, and I want to use the temporary credentials from the IAM role that are associated with this instance. So just keep entering, it will automatically pick that up. And now it will ask you, do you want to use the default configuration that Copilot selects for this particular service that you're going to, for this particular environment that you're creating? So now, once you've done with your credentials, you can also check that do you want to use the default one, that is create a new VPC with 2 observability zones, with 2 public subnets, 2 private subnets, new ECS cluster, and new IAM roles to manage these services and jobs in your environment. Do you want to use these default configurations, or do you want to use this, but do you want to configure a few items from these default configurations itself? Or do you not want to create anything new, but you want to continue using or import your existing resources that you've already created? So let's go ahead and just go with the default operation for this example. Once I say use default, it will go ahead and start linking my account and the particular region that I've given for this environment to my application. So for that, it actually goes ahead and creates CloudFormation stacks again in the backend for me. Again, if you want, you can just stay on the screen and wait for it to come back and respond to you. Or if you are interested to know what is happening, what is the magic behind Copilot, just go to CloudFormation and you will see a new stack is now create in progress. If you go to events, you can see that there are some KMS keys and some S3 buckets that are the different resources that Copilot needs for itself, and it's creating those resources. You just refresh, you'll see the status of the CloudFormation stack. Looks like everything is created and it's just waiting for the KMS key to be created. So let's give it some time. So what I'll do is will fast forward this when I'm recording this, so that you don't have to wait for 5 minutes or 2 minutes or 5 minutes, depending on whichever stage we are. I'll also give you a little bit breather while this is running. So there's few seconds left. You can sip some water, get some coffee, and we will definitely go there. Great. So it has completed creating this environment. You can see what all it has created. IAM role, ECS cluster, security group, virtual private cloud. Everything's created. You can see how long did it take for it. And it's saying created environment test in this particular region under your application SM. Awesome. Sounds good. So we'll again repeat the same thing but for our production environment. So again, I'll copy the same command, and here I'll name it as prod, but instead of region AP South 1, we may create in a different region. Maybe here I'll select the Tokyo region or AP Northeast 1 to create my production environment. I will still use the default configuration that I want, and I will now name it as a flag as prod. Uh, I'll show you why this is important when we go into the pipeline creation. Okay, so I'm just confirming it was AP Northeast 1. Yes, it is AP Northeast 1. So Sydney is Southeast 2 and Tokyo is Northeast 1. Awesome. So let's press enter. Again, it will ask for temporary credential. Just keep pressing enter for that. Just pressing enter, and that should now create the similar items for the Tokyo region. Because it's a different region altogether, it will have to associate that region with this particular SM app. So if you go to the console, select the Tokyo region, and you can see there is another CloudFormation stack that is create in progress for this particular region. And it's again creating the buckets and everything that will be only restricted to this region. This is again going to take few seconds, or actually few minutes, but few seconds for you. So let me just go ahead and fast forward this for us. Awesome. So it has finished creating your environment in the Tokyo region, and it's a production environment, and it has started with your social media app that you have created. Great. So let's check out quickly what have we done so far. So you say Copilot app show, and it should tell you that, hey, this is a social media app. This is the version of it. And we have two environments as of now. That is a test environment and a production environment. Which account and which regions have you hosted that? So remember, I mentioned that you can create environments in different accounts, different regions, and this is how you would create it in different regions. Now let's go ahead and create a service. So Copilot service init. And here we are going to create a user service, right? We are not creating threads and posts just for the demo purpose. We are only going to create the user service. So you say, hey, I want to say that this is a Docker file. Where is the Docker file for user service? What is the name of the service? It's users. And we also want to say, what is the service type? Remember the 4 types that we discussed during the presentation. So that's a load balanced web service. Okay. If you don't want to mention all of this, you feel that, hey, I don't know what to write here. Am I writing it correctly, incorrectly? You can just remove that and you can just press enter. And it will again ask you, what do you want to create? These are the few options that you can create this in this particular environment. So here I can just select load balance web service, because that is our example where we want a load balancer in front of our um, container images, right? So let's go ahead and create a load balance web service. So the moment I do that, it will again go ahead and create the ECR repository for the service users. The moment you press enter, you can see there is a new folder called as users, and there is a manifest.yaml created for the user service. So now I can let it run for a while. That it will take a few couple of minutes maybe for it to finish doing that. So let's go ahead and check out the manifest file. Oh, okay. So it has finished creating the ECR repository. So for the particular user service. So the next step or the recommended follow-up action is to update your manifest file, the manifest file that we're going to check out now. If you want to change any defaults, and then you just go ahead and deploy the service for the test environment. Okay. So let's go ahead and check out the manifest file. And you will get a manifest file for all the different services. So you can change these defaults per service that you have deployed using Copilot. Right. So the name, you can see what is the type of it. It's a load balance web service. You can see, okay, it's using HTTP. What is the path going to be for this request? Then you can see what is the image. Right now it's using a Docker file, and where's the Docker file for building that image, which is then pushed to the ECR repository for the service users. You can also find what port it is running on. You can change the CPU and memory requirements for your containers here. Initially, it creates everything by default. We are not changing that. You're also keeping it at default. However, we will be changing something here for the service where we can override the values defined by the environment. Remember, we have test and production environments, right? So what I'm going to do is, let's say in test environment, let's just copy this first and create a prod environment. Okay, so what I'm saying is in test environment, I only want one task, whereas in prod environment, I want two tasks of this particular service. Okay, let's change it to prod. So here I'm defining the service definition. Okay, I'm telling the service that, hey, whenever you're going to be deployed in any of these environment, how many tasks do I need? Obviously, for an example, I'm just saying one or two, but in real life, you would have more tasks that you will create. Now save it. And what is the next step? We have to just go ahead and deploy this service. So let's just copy this for now. And we will now deploy this user service into the test environment. And let me just increase the window size. Okay, so what is happening here is the moment I press enter, it is now building the image, the Docker image based on your Docker file, and it will now push that Docker image to a ECR repository that it has created in your account, and it will push it to that. Once it's done that, it will also update the task definition, and it will go ahead and update your test environment saying that, hey, there is a new code that is available, there is a new settings that is available. Now go ahead and apply these. Now this also takes another few minutes for it to finish and update the stack. So let me just fast forward this for you. Awesome. So it has done creating and updating my environment, and you can see that it has now created just one task depending on what I had given in the configuration. So there's, yes, one task that is required and it is running. You can deploy the user's service to the environment and you can access it at this particular URL. So let me just copy this and open it in a new tab. And yes, the service is up and running, but to access that particular service, I've given this in the rules section. So you can just say /API/users. And this should open up the output from that particular now obviously this is just a JSON file that it is displaying, but in your application it could be a real world scenario when you're accessing that service. It's great. So now that hosted the service in the test environment, we'll do the same thing for our production environment. So it's the same, use the same command, but just change the environment from test to prod. And it's doing the similar things because your prod is in a different region and your prod is an independent environment on its own. So it's going to redo the same thing, that is build the image based on a Docker file, push it to the repository that you have in that particular region. Okay, ECR repository to that, and based on the tasks counts that we have given. So test had 1, but in production we should see that it has created 2 tasks for that same service. So let's fast forward this again. Great. So it has now deployed this to your production environment. And now you can see that there are two tasks, and there are 2 tasks that are running for this particular revision, depending on the configuration that we had. So again, if I want to access this, I can just go ahead and access this on this particular URL. This is a Tokyo region URL and not the other one that we saw previously, right? So the same thing, add API/users, and it will have the same data that we saw in our test environment. And that's it. So now you've created an app, you've created 2 environments, you've created 1 service that is now deployed in both the environments. Okay, so let's go ahead and check that quickly as well. So there's Copilot, app, show. Now it should have changed, right? So now we can see that, hey, again, the same name, same version, true environments, but now we also have a user service. There's nothing in the pipeline section for now. So if I want to see where these services are deployed, I can just do Copilot service show. Okay, so it's a, hey, I only found 1 service that was user, so I'm just defaulting to that. And you can find, hey, which application, which users, what kind of service it is, what environments, how many tasks per environment, what are the CPU and memory requirements for this, what is a port, how you can access these different environments. So both are different URLs. These are 2 different environments, and any more variables that are associated with these 2, both the environments. Okay. Now with the latest update, you can also provide something called as alias here for HTTP path. We will talk about this a little bit later in the session. I will show you where you can find more information in the document for that. So now that I've created these environments, I also want to check out at how we can easily create some pipeline where I've pushed certain code to my user service, and when my code has been pushed to the user service, I've made some changes, I push it, I should automatically go ahead and build a Docker image, push it to my test environment. Once it's done to test, go ahead, test it, and then go ahead and push it to my production environment. So we can create an easy pipeline. You don't need to know AWS components, how to do that. You can just create that release pipeline easily with just 1 command. Okay, so that command is Copilot pipeline init. That's it, as simple as that. And once you say that and you enter, it is going to ask you, okay, so which environments do you want to add to your pipeline? So if you could have more than 2 environments, for example, we have test and prod. So our first stage is always test, and then once it's passed, we will go into our production environment. It will ask you which repository would you like to use with this. Now here I'm just going to use the same GitHub repository that I've configured because I've been using that GitHub repository. So I'll just push to that same GitHub repository. Awesome. So now it is saying that it has wrote a pipeline manifest, and you can see that there are pipeline.yaml and buildspec.yaml. There are new files in the Copilot folder. The pipeline.yaml is required by code pipeline, and buildspec.yaml is required by the code build service to build your Docker images. Now, if you want to change anything, change any settings here, not use the default ones, you can just go ahead and update these settings. So for example, you want to add some unit tests to your application before the images are being pushed. You can update the build phase to add more unit tests, and it will automatically run those unit tests. If the unit test pass, then it will push those images. If not, it will fail at that particular step. Okay, and code pipeline has information as to what are the different stages in your pipeline. So first one is obviously source. Where is the source coming from? Where is the application source code that you have, which branch it is working for? The next one, once you make any changes to this code, it will automatically start the pipeline. The second is obviously build, and then you have test and prod. I will try and show this to you in an easy way if it is not feasible to understand what is happening in the text document. So hang in there. Okay. So now what we will do is now we will add all these files to our Git repository. Okay, so I'm just adding all these pipes like pipeline.yaml and the build spec, and there's a workspace. I'm just committing saying that, hey, I'm adding pipeline artifacts and I'm just pushing this code to my GitHub location. Okay, now that should be done quickly. And once that is done, uh, it should have updated my GitHub location. Now we have just pushed data to my GitHub location. Okay, we have not created a pipeline yet. It has just created these files that it needs to create the pipeline. So let me just quickly open up code pipeline in the AWS console. You just go ahead, search for code pipeline. You will see that there is no pipeline in either of the region, nor in Sydney, nor in Tokyo. Okay, so we've just created the manifest files. We have not yet deployed the pipeline. So what do you do for that? If you want to make changes, you can make changes, and then you can say, hey, Copilot pipeline update. The moment I do that, it will now go ahead and create the pipeline for all the resources that we need here. Now here, because I have not used GitHub with my code suite before, so that's why it's asking me to accept the connection for GitHub. Okay, so it's giving permissions for it to access GitHub. So I'm just going to authorize that GitHub connector. It just needs it via the app. So I'm just going to install a new app in my GitHub repository for this particular Git and allow that. Awesome. So once that is done, once the connection is successful, it should automatically pick this up. So yes, that is available. Okay, so now it has successfully created the pipeline, and awesome. I will go back to the AWS console, and you can see that, hey, my source has been the source in GitHub. So if you want more information, you can always check out what is the source. So repository ID is definitely the same. And now it will then go to the build phase. If you want more details, you can always click on details, and you can see more information on the build status, on the certain logs that you can find, what are the reports, etc. What is the resource utilization, because you will be paying for these particular resources. So let's go back to the pipelines and check out what is happening. So now our source phase or is done, our build phase is done, and it is now deploying to the test environment. Once this is successful, it will ask you for deploy to the prod environment. But before going to prod environment, it will definitely ask you for your manual approval that, hey, do you want to definitely push this to production? If you feel that your tests have been successful and you do want to push this to the production environment, then definitely go ahead and approve this, and it will automatically go ahead and deploy this to production environment. If you don't want to check it out in the AWS console, I've shown it in the AWS console because it's easier for you to visualize what is happening. You can also check this out in the Copilot command line. So you say Copilot pipeline status, and it will ask you which app, and you can see that yes, it has succeeded to, it is in progress for the deploying to test environment, and deploying to prod has not been deployed yet. Great. Let's see what Copilot pipeline show displays. And here you can find information. Okay, what is the name of this pipeline? When was it created? What is the source? And where is the build project? What is the CloudFormation name or stack name for your deploying to your test environment? So let me just switch to the uh, code pipeline environment. And again, if you need more information here, you can also click on details and it will take you to CloudFormation. And in CloudFormation, you can find the stack that it has. It is now going and updating with all the details. Still opening. Great. Let's close this. Yes, our stack is update in progress. It has created before and now it is being updating as per our new task definition that it has created for the new code that you have published. Great. So now you can see that it has completed pushing the update, whatever update I had done to my source code to my test environment. I can go and check out my test environment. Okay, if everything is fine. I mean, it's a hypothetical situation right now. And once that is done, I can go back and say, hey, everything looks fine. Now I want to provide a manual approval for it to be promoted to production. Test environment looks good. Push to prod, approved by Rohini. Okay. If you want, you can also put it in Markdown and you can say, do you want to approve or do you want to reject? Let's say we approve this. Now, once you've approved this, it will automatically go ahead and push this update to your production environment. Just give it a few seconds and it should automatically go ahead and start pushing to your production environment. And in this case, what will happen? Similar to your test environment, it will now go ahead and update the CloudFormation template for your users in the prod environment, user service in the prod environment. So if you want to know more details, click on details and it will open up in another window. You can see that now the stack is update in progress. So it will update the task definition with your a new build and it will image and it will go ahead and update this particular service. So that's the simple demo of what was happening in this case. But hey, we didn't just want to create a pipeline. So let me see if I can show you a simple demo of pushing some kind of data. So let's see, I'm using some db.json in this case. So let me, right now you can see, hey, there are 4 IDs in your data. So what I want to do is maybe add something like ID 5, username Rohini, and this is Copilot demo, and we are using Cloud9 to showcase Copilot. So now, this is just to showcase that I've made some changes to my application. Now, in your case, it could be a bigger change that you've made to your application. In this one, I'm just showcasing, I've done a smaller change to my application. What would you do once you've done changes to your application? Of course, as a normal developer, I would go ahead and update this into my Git location, right? So I'm just going to say my commit is added user ID 5. Okay. And once I say I'm done with this, everything looks okay, everything is saved. Yes, I will push this to my GitHub location. And now that I've pushed this to GitHub, what should happen is code pipeline should automatically realize that new has automatically realize that new code has been pushed to GitHub. GitHub will then send a message to code pipeline saying, hey, new data is available. You need to push this to your test and your production environments. And that is what has happened here. Automatically, this has gone into the source has been updated that, hey, now you've added user 5 as an ID. It will automatically build the container images. You don't have to do anything. Once the container images are being built, it will automatically go ahead and deploy this to the test environment. So let me see if I can fast forward this for you and show you that this has been updated in your test environment. Meanwhile, our prod is still getting updated and it may take another minute for it to be updated. Great. Now my build has been pushed. So let's go ahead and check that it is automatically going to deploy to my test environment. So let me scroll down. So you can notice my test environment has the source code of user ID 5, whereas my production is still running the older source code of where I had updated the infrastructure folder name. Great. So now you can see that this user ID 5 source code has been deployed to our test environment, and our old environment has not yet received the update. It's still running the older version because I have not provided the manual update. So let me go ahead and refresh, and you can see that automatically this ID has been updated. So you can see that what did I do here? So just to recap, what did I do here? I went ahead, made changes to my code. I only simply did git push to my Git repository. So I only did git push to my repository. The moment I do that, automatically code pipeline picked up that okay, there was some changes made to the source. It built the image, it updated the task definition for ECS, and it deployed it to the test environment. And you can automatically check that in your test environment. Now, if this looks all great to me, what do I have to do next? Yes, you're right. I have to go ahead and approve this test. Looks good. Okay, and I have to go ahead and just approve this, and this will automatically now be deployed to your production environment. Meanwhile, your production is still running your older version of your application. If you don't like the version, you can just always roll back. So in this demo, I would like to conclude that we used Copilot to create an application that has two environments. There's a test environment, there's a production environment, and here we only deployed one service called as the load balanced web service. Now, if I want to deploy more services, I simply have to repeat the commands to deploy the different services in there. The pipeline will have to be just updated with all the new services that I will be deploying. So until now, we saw how you can build your applications quickly with Copilot. You can create your release pipelines using Copilot. But now let's also check out quickly how you can operate or you can find more information about the health of your environment, about certain logs for your different services that you've hosted. So for example, what we will do is we will look at Copilot service. Okay, and you can see Copilot service help. So when you do that, you can find the commands for the services. What are the different commands that are supported for a particular service? So obviously we've seen initialization of a service, we have deployed a particular service. We can also see what is more information about the deployed service. We can find a status of that service. We can get the logs for that particular service as well. And you can also execute a command in a running container that is part of a service. So in this example, let's say Copilot service, show me logs. Now it will ask you logs for which application if you have multiple applications. Now, in our case, we have user service in the test environment and the user service in the prod environment. So it will ask you which services logs would you like to show? Is it the test environment or is it the prod environment? Let's go and check out for the test environment. The moment I do that, it will show you it will tail the logs that have been collected by the service itself in CloudWatch, and it will showcase that to you. If you want to see more information as to, let's see, status, so we can say Copilot, show me the status of this service. Again, it will ask you application, and it will again ask you which environment. So let's go with test environment itself. And here you can see that it will show you a task summary of how many tasks are actually running, what is the health of these different tasks, what kind of task definition revision are these tasks running. So you can see that this is the ID of the task, its status, its revision, when did it start, and is it healthy or is it not healthy. Let's go back to the presentation and recap what all we did in this particular example. Now, We have already seen these activities. So let's recap quickly what were the CLI commands that we executed. We created an application to initiate the social media app. We initiated an environment for test in AP Southeast 2 with the default config. We created another environment for our production environment in AP Northeast 1 with a flag called as prod. Then, for every service that we will need, so we started only with user service. We initiated a service for users, and its type was a load balanced web service, and we provided nothing but a Docker file. We then deployed the service to our test environment. We then deployed the service to our production environment. And we saw an output for the services as to when they were finally deployed. Now, after doing that, we created a code pipeline as well. This created number of artifacts that we finally added to our code and pushed it into our code. Once that was done, we updated our code pipeline to consider that any code that will be code changes that will be made will now be automatically picked up and run through the entire pipeline. We also checked out the code pipeline status using the terminal itself. Now that we've talked about all of these concepts, these are a little beginner concepts. Now, if you want to check out some advanced concepts, you can check them out in the AWS Copilot documentation. So you go to AWS GitHub.io Copilot CLI and you can find more information here. Let's click on Get Started. When you click on Get Started, you go to the documentation. You can find installation information here. You can also go to Developing and find more information as to, let's say, how you can add a domain name. Remember the URL we used to check out our application? That was created using this kind of format. But if you want to have your own alias, then you can also mention that in the manifest file. We then also can create sidecars. Now, sidecars are containers that can run along your main containers. So you can have more, perform some peripheral tasks like, you can have logging or tracing or more information or configuration that you want to have for your containers. And lastly, you could also add storage components through your Copilot. So you can create something like S3 bucket, or you can create a DynamoDB table, or you can also create an RDS Aurora serverless. You could also integrate your EFS volumes with your Copilot systems. So here we can find all more information on you if you want to do additional advanced concepts. So finally, what is that we wanted to have? And my friend was such a hurry that he saw like, okay, this is what it is. And I'm so interested to try this out. So my friend has already run along and is now going to try out Copilot. So what are you waiting for? Check out the repository for code samples, the explanations. You can also find all these references there. So please do check it out and let me know if that was helpful and if there's something else I can do to make your journey of containers on AWS a little bit simpler. So thank you for this session. Please go build. Thank you.